Assalamualaikum warahmatullahi wabarakatuh. This is Ikmal Danial Adam and Idriz Hafiz group, and we are going to present about arithmetic and geometric progression. Okay, so first we're going to look at arithmetic progression. Arithmetic progression is a linear sequence such as 5, 8, 11, 14, 17 and so on, which each term differs from the term before by a constant. For example, from this statement, the common difference, which is d, is 8 minus 5 equals to 3, and the first term, which is a, is equal to 5. So, to find the nth term, we use a plus n minus 1 times d. So next we move on to the sum of an arithmetic progression. When the terms in a sequence are added together, we call the resulting sum a series. The formula we use to find the sum of an arithmetic progression is Sn equals to n over 2 times a plus l, which is l is the last term, or Sn equals to n over 2 times 2a plus n minus 1 times d.
Alright, so we will move on to the geometric progression, which means that is progression of a number with a constant ratio between each number and one before. As we can look at the left side, where the consequent is 2, 4, 8 and 16, and a is the first term and r is a common ratio. Alright, so we look at the right side, where the formula for the term is n term is equal to a r to the power of n minus 1. Alright, let's try this question. This question is about the term geometric progressions. So the first one, we need to find the second term in the form of the formula. So it was like AR is equal to 12, and the fifth term, AR to the power of 4 is equal to 40.5. And next step, we will make the ratio between the two terms that we get. The fourth or the fifth terms over the second terms is equal to the real number of the terms, and we will find the ratio of the progressions, and we will get the exact value of the first terms by using the formula. Please remember, we need to use in term of and we got the answer. Alright, for the next part of the geometric progression is the sum of the geometric progression. At the left side, we can see the formula of the sum for the ratio less than 1. And the right side is the formula for the ratio more than 1.
Alright, now let's we go to real life applications. In arithmetic progressions, usually we will see it when a child get their allowance from their parents. For example, a weekly allowance of $4 with a promise of a $2 weekly additions leads to the following pay in the first 3 weeks. This gives an arithmetic sequence with the first term being $4 and the common difference being $2. Let's try this one. Lee earned $250 in the first week, $350 in the second week, and $460 in the third week, and so on in an arithmetic sequence. How much did Lee earn in the first 5 weeks? So here we know that $240 is the first term and 110 is the common difference. We can use the sum of arithmetic progression to calculate the answer. In geometric progressions, we can use it to calculate the population growth. Say that the percentage increase was 3%. The common ratio can be found by adding the percentage increase of 3% and 1. Formula shown below shows the method to calculate the population growth. Let's try this one. The snake population in a Kuala Pilah town was estimated to be 320,000 in 2012. Scientists believe that this will increase by 2% each year. So, what will the snake population be in 2015? From here, we know that the first term is 320,000 and the common ratio is 1.02. So, we can use n-term formula in
Geometric progression to calculate it.